All right, today we're diving into something called the Quantus Network. Now, this is a blockchain project that's trying to get ahead of a massive future threat, one that could literally break, well, everything. So let's get right into it. I want you to just think about this for a second. What if a totally new kind of computer just appeared and it could break every single digital lock out there? We're talking passwords, bank accounts, your private messages, and yeah, your crypto. This isn't some sci-fi movie plot, This is actually where we're headed. So, what is this magic machine? It's a quantum computer. And look, it doesn't think in ones and zeros like your phone or laptop. It plays by the wild rules of quantum mechanics. This lets it crush certain types of problems, specifically problems that are impossibly hard for our current computers. And it just so happens that our entire digital security system, all of it, is built on one of those impossibly hard problems.
Okay, so that brings us to the big one, the quantum threat. What does this actually mean for blockchains, for the entire crypto world? Let's break it down. Well, for starters, a powerful quantum computer could look at your public key and just figure out your private key. Just like that. An attacker could then sign transactions as you and just empty your wallet. Gone. On privacy networks, they could fake proofs and print money out of thin air. They could peel back the layers on private transactions and even start to chip away at the very hash functions that chain the blocks together. It's a total breakdown. And, what really stands out from the source material is just how serious this is. They're not talking about a small bug or some little vulnerability. The term they use is catastrophic system failure. Think about that. The entire trillion-dollar crypto economy is basically standing on a cryptographic foundation that quantum computers are getting ready to just shatter. Okay, so there is some good news here. Cryptographers aren't just sitting around. They've been working on a fix for years, and it's called post-quantum cryptography, or PQC for short. These are brand new algorithms designed to stand up to both regular and quantum computers. Awesome, right? Problem solved? Well, not so fast. Because like a lot of things in tech, when you solve one problem, you often create a brand new one. And this new one, it's a doozy. And here is that new problem, laid out perfectly. A normal signature, say on Ethereum, is super small, only 65 bytes. Tiny. Now look at one of the top PQC options. It's almost 2,500 bytes. That's not just a little bigger, it's over 37 times larger. Can you imagine if every single transaction on a blockchain suddenly got that bloated? The whole network would slow to a crawl. It just doesn't scale. So that's the big question, right? How do you get that quantum-proof security without completely wrecking the performance of the network? Well, that is the exact problem that the Quantus network aims to solve. And I love how they put it. Their goal is to be a future-proof fortress for your fortune. So they're not trying to be the next everything platform with smart contracts for games and whatever. No, they are laser-focused on one single thing, preserving wealth in a way that's scalable and, most importantly, quantum secure. So how do they actually pull it off? How does Quantus get around that huge data bloat from the PQC signatures? Well, it all comes down to a really cool innovation they call entangled addresses. And the result of this tech? It's kinda nuts. We're talking a potential 223 times improvement in how many transactions the network can handle. That doesn't just fix the scaling problem, it completely obliterates it. So you're probably asking, how on earth does that even work? Okay, so on a high level, it's actually genius. Instead of cramming hundreds of those giant signatures onto the blockchain, which would be super inefficient, entangled addresses let you bundle them all up off-chain. Then you generate one single super compact proof, a zero-knowledge proof, that basically says, hey, trust me, all these hundreds of transactions are valid. All the network has to do is check that one tiny proof instead of all the big signatures. It saves a ton of space and time. But that's not the only trick up their sleeve. Quantus has this other innovation that is, honestly, just as cool. It's this wild idea where they take the main threat, the quantum computers themselves, and turn them into a feature of the network. It's called the quantum canary. So the network has this unique proof-of-work system for mining. Now, it's not like Bitcoin where everyone's racing to solve the exact same puzzle. The puzzle on Quantus is special. It's designed so that both regular computers and quantum computers can work on it, but they go about it in completely different ways. Here's how this quantum canary works. Step 1. A new block creates a really hard math problem. For the nerds out there, it's an RSA problem. Step 2.
All the normal computers start grinding away looking for a close enough solution. If they find one, they get to mine the block and get the reward. But here's the kicker, step 3. A quantum computer can find the perfect, exact solution. And step 4? When one of those perfect solutions shows up on chain, that's it. That's the alarm bell. It's public, undeniable proof that powerful quantum computers are officially here and active.
And that is the whole canary in a coal mine idea. It's brilliant, right? The network actually pays quantum computers to show up and play. It gives them mining rewards to help secure the network, and in the process, it pays them to announce their arrival to the entire world. It turns into a global early warning system that the quantum age has begun. Okay, so all this super deep quantum-resistant tech is amazing. But protecting your wealth isn't just about fighting off future supercomputers. It's also about protecting us from ourselves, from simple mistakes and everyday scams. This is where Qantas builds in some really smart, user-friendly features right into the core protocol. For instance, you can put a time delay on a transaction, giving you a window to cancel it if you realize, oh no, you sent it to the wrong address. You can also set up high-security accounts that need a second device to approve any payment going out, which stops a thief cold. And you can set up a recovery address, which is basically like an on-chain will, so your funds aren't lost forever if something happens to you or your keys.
And this feature, this might be my favorite, just because it's so simple and so smart. You know that heart-stopping moment when you're checking that long, random string of letters and numbers for a crypto address? Well, here, the network also gives you a simple, human-readable phrase, like ocean candle lion. So before you hit send, you just have to check that those 3 simple words match up. It's such an elegant solution to prevent what could be a really, really expensive typo.
So you've got all these amazing features. What's the plan for the future? How is a project like this supposed to handle all the uncertainty that's coming?
Well, they have a pretty clear roadmap laid out. It looks like they kick things off around December 2024, with a public testnet coming in mid-2025, then a public beta, and finally a main net launch in the first quarter of 2026. And it's interesting to see that the entangled addresses tech, which is so key, is planned for a bit later in 2026. So they're definitely rolling things out in phases.
Now, no project is perfect, and to their credit, they're pretty open about the risks involved. You've got your usual software bugs, of course, but also these new PQC algorithms are, well, they're new. There could be flaws nobody's found yet. And the biggest unknown of all is when these powerful quantum computers will actually arrive. Plus, there's always the challenge of adoption and regulation.
And that's exactly why this next part is so critical. The entire network is designed to adapt and evolve. It has on-chain governance, which means token holders can actually vote on upgrades to the system. So if a brand new, better algorithm comes out, or, oops, a flaw is found in the current one, the community can vote to swap it out smoothly. No messy hard forks. The network can literally change as the world changes.
And that really brings us full circle, back to that first big question, the quantum age. It's not an if, it's a when. Could be 5 years, could be 15. Projects like Qantas are out there right now, trying to lay the groundwork and build the fortress before the attack comes. The real question is, when that day arrives, will our digital world be ready for it?